we finally have 10 people here. All right. So let's see. Where is here? Right. So now I'm just going to go through some of the slides. No, I'm not going to tell you what is research. So the thing about it is, one of the things you should all know is that all types of research projects that you're going to write or conduct should be because there is a good compelling reason to do it. So one of the things that we showed you is this particular slide, which shows that there are different types of what is called research gaps. Anybody remember what a research gap is? What's the basic concept? Don't all speak at once.
When there is not enough information about the topic or enough information found about the topic.
Exactly. So like the way how you've described is basically the evidence gap. So the evidence is there are some results, but either they're contradictory or like the one that you, is another one, or what they call knowledge gap here is that there is like nothing on it. So there's either paucity or there's contradictory. But there are other things. It could be that there's evidence, but it's not about how to put it into practice. It could be that there's evidence, but maybe there are new kind of research methods that can be done to generate new insights. It could be that there is evidence, but it's not empirically verified. So for example, let me give what that means. That means, by the way, not going to test on this, I'm just showing you. It means that you might do a study in an artificial environment, but you don't know if it works in real life. So that's what is an empirical gap. Theoretical gap means that there's no theory that explains what the research is all about, and that's a whole story by itself. And the population gap means even though there's research in some populations, we're not sure that it applies to the population that we want to know about. And so we decide to do research in that area. So a lot of you tend to talk about the population gap. And if I want to just tell you something as a general note, when you do a literature review, you should not only talk about population gap. Usually you're expected to also talk about some other kind of gap as well. Because usually there's more than one type of gap, usually. And so when you do lit review, you're supposed to say, what are the types of gaps? But the point is, at least one gap should justify the research question. Yes. So I don't need to go through any of this because I think at this point you should have an idea what the concept paper is, we hope. And everybody knows why you do research questions, right? So this tells you that there is what questions or why questions. What's the whole point of writing a research question in a study? Why? Anybody? This is not on the slide anywhere. So you need to have a problem statement which states what the problem is all about. But in addition to the problem statement, you have a question. What is the whole point? And that question is going to have some variables, at least one variable. And if there's a relationship, an independent variable. But what's the point of having a research question in a project? Nobody? Let me go it again. What's the point of doing any academic research? It really is to either test a hypothesis, which is what this says right here, or to answer a research question. So there, that's beyond what we actually said in the lectures. People tend to, depending on the discipline, they tend to present the point of a project in one of three ways. Either people tend to write research questions, or they write these things called hypotheses, or they talk about the aims and objectives. And it depends on the discipline as to which of those three things that they talk about. What I've taught you in this class is research questions. And we just mentioned quickly about hypotheses. Generally speaking, you don't, for computing, you don't need to worry about the hypothesis until you get to the master's level. But I mean, if you remember back in the high school, you actually looked at hypotheses in the sciences. So hypotheses are not something that you can understand, but that we didn't focus on that in this class. But one thing that's on this side, which is very important, you remember this notice here, it says research sets out to test a hypothesis, not by proving it. It's looking for evidence supports or does not support it. Why does this thing have this big sign about proving? Can one empirical study prove anything? This is a yes, no question.
No, teach.
No, why not? It's actually kind of complicated, but if you remember when we went into this whole thing about statistical significance, the idea is no matter how big your sample is, there's some chance that your sample does not represent your population. No matter how good your study design is, no matter how good you do a probability sampling, since there's some chance that your sample doesn't represent the population, one sample, even if it suggests or strongly suggests that there's a relationship between two variables or whatever else it suggests, one study don't prove anything. So don't finish a study and talk about your proof. Proofs only come from many studies together. Why? Because if you have many studies and they show the same thing, then it is likely that those studies together might prove. Right? Then on from that, we don't need to worry about this right now too much. I'm trying to remember when I have 1 hour going through some of the most important things. So that was a highlight of some of the things that's important in my second lecture. I skipped research lecture number. I skipped research lecture number 3 because I don't think anything there needs. I mean, you can go over it by yourself. So I need to have a good idea of this. So let's move on to here. Just go to right. If we have enough time, we could go back to lit review, but I think by now everybody should have a fairly good idea of literature review. Questions can come from it, and I'm just going through some things that tend to be hard to remember and understand. So moving on. So this is going through some of the things we did before. Remember, we actually learned about different types of published reviews. There actually are 3 types. So I don't have the 3rd type here, which is called a narrative review. But of the ones that are really important, there's something called a systematic review and a meta-analysis. Systematic review is a study that collects meta-analysis, we could start with this one. Meta-analysis takes quantitative data from many studies and essentially does a statistical analysis to see if there are trends answering one or more research questions. The systematic review is a qualitative review of many studies in order to answer a research question. The biggest difference between the two is meta-analysis is a better study because it uses the quantitative data to answer the questions. So you can be more certain of meta-analysis than a systematic review, but both are considered excellent studies to review. Why? Because they give a comprehensive review of a topic if the study was well designed. So there's this other thing called a narrative review, which I didn't show on the slide, which is what you did for your assignment. So a narrative review is where the researcher or researchers essentially select some papers and write about a topic without doing it in what is called a systematic way. Let's not worry about how you do it in a systematic way, but you should all know that these are the better types of reviews than narrative reviews. And you can go through and read what this says. Don't have time for that right now. You should know that when you are summarizing your method in an abstract, you want to always, at the end of a study, or when you're proposing a study, you always want to talk about your research design, your sampling method, and your data collection instruments, right? So we're going to talk about each of them enough for the rest of this class so you have some idea what this means. So in fact, usually you just call these things instruments. You don't call them data collection instruments, but all instruments here are used for data collection. Remember, they can be qualitative or quantitative or both. So we talked about many different types of research designs, and in a very broad sense, no matter what, at the end of this class, you should know what are descriptive research versus experimental. So some people, when they introduce undergraduate students, they only talk about these two alone. Nobody even get into all of these, which are all real types of research. So no matter what, when you're reviewing, please understand these two things, because we're going to limit the amount of but these are all real types of research, so these that are plausible for research. So let's see. Remember, descriptive research essentially are correlational, they have to be correlational alone. So they're basically typically surveys, right? You don't manipulate the variables, you're just collecting data by observation. Now, either you're doing a census, which is the whole population, which is not known in a research study, or you're doing a sample survey, which is a subset of the population. Many surveys are self-report, as in it's not administered by a researcher or data collection person. And so if that's the case, there are possibilities of errors. So you should know the difference between a cross-sectional survey and a longitudinal survey. Cross-sectional survey is a snapshot, and a longitudinal survey is over time, where you collect data with at least 2 or more times. The idea of a cross-sectional survey is you need to figure out what are the characters you want to study. You always want to figure out an instrument, and that instrument, data collection instrument, should be one that is going to collect data that is valid. Because at the end of it, if the data collection is not representative of what you really want, then it's garbage in, garbage out. So it's always better, if possible, to use an existing instrument than one that you make up from scratch, if possible. It's very important to figure out what is the appropriate sampling method, and then to administer the instrument, etc. And then there are different types of longitudinal surveys. My simplest way of distinguishing a cross-sectional and a longitudinal survey is cross-sectional is one time. And by one time, we don't mean at a single point in time. Sometimes a cross-sectional survey can even go as long as a year. Can you believe this? The idea is that it's supposed to be at one time, and usually that's within less than a month or 2. But sometimes some cross-sectional studies take so long that it can take longer than that. So I can give you an example. I was part of a cross-sectional survey where it took months for them to collect the data, because it was all across Jamaica, an expensive study. And since they do that study every 7 years, even though it took them a few months, it still represents what happened in that year. Yes. So in contrast, a longitudinal survey is trying to say, for any particular participant, we're collecting that data at least 2 or 3 times. So if, for example, you wanted to know how the SCIT students in year 1 grades change over time, right? You could do that with a cohort study, where you can, like this says, a study amongst children entering first form. So it could be first year or UTech, and you look at them all the way through. You could figure out what their careers are going to be. That's a cohort survey. A trend survey is you could look at other second-year SCIT students and just keep looking at what happens for second-year SCIT students over time, right? Panel survey is similar to the cohort. You're collecting data from the same sample over time. So for survey research, you're going to define the problem, define the target population, and collect the data. Let's work from that. Now, we all should know by now that experimental research is considered what is called the gold standard. Why is it the gold standard? Because of the first line right here. It investigates cause and effects. So where possible, if you want to do an intervention of any kind, you always want to know if the intervention works. So I would say maybe 80% of projects that people define for themselves in my tutorials, people wanted to do experiments. So we had everything from people wanting to, yes?
Are you sharing the screen?
Yeah, you're not seeing it?
No.
Oh, I thought you were seeing my screen. All right. Share screen. You seeing it now?
Yes.
Okay. Yes, I was actually looking at the screen all the time from present. I don't know, where is this? Right. So for the experimental research, you wanting to look at, oh, I guess I just said this. You want to look at cause effect. And I had everything in my class on people wanting to look and see if there was some evidence that, let me see, chat box. There already evidence from literature that chat box has can be used to treat depression. You had another group wanting to look at the impact of the differences between face-to-face versus online impact on the social the social interaction of people. What is what I wanted as an example? There was a project looking at the effect of social robots on elderly populations. In fact, I have to look a little bit more. Almost every group that I had in my class wanted to look at the impact of something on something else. And if you want to look at the impact of something on something else, like even had people want to look at the impact of different ways to approach education during COVID. Even when that wasn't the case, almost every project in my classes that people chose, basically people wanted to have at least one research question that was about cause effect. And if you want to look at cause effect, essentially what you need to do is experimental research. And when you do experimental research, you actually need to figure out a way to manipulate one condition that's called the independent variable and see if it has an impact on the dependent variable. If you're unable to do that manipulation, either because of ethical problems or because of practical problems, then you can do what is called an observational study. There are other kinds of longitudinal studies that are not experimental, but you won't be able to determine cause and effect relationships. So there are other kinds of longitudinal studies that are experimental, but they're not going to tell you about cause effect, right? So, and you can read about that and you go, we're not going to do that in review. So the problem with experimental research is you can see relationships, but those relationships may actually be caused by something else. So the important thing is both using your common sense as well as reading the literature as to what other things may have an impact when you're thinking about two variables. So if it's, for example, if you want to figure out if a new educational pedagogy or tool could improve academic performance, given that there are so many other things that affect students' academic performance, like stress levels, financial problems, aptitude in the class, rah, give me a long list of things. That's what I mean by rah. You need, if you don't actually also measure the most important other variables, you're not going to be able to say whether what I was just saying, like a new educational technique, actually impacts the academic performance. So when you do experimental research, you need to figure out all the important variables and measure for them, and if possible, control for the extraneous variables. So does anybody know what I mean by controlling for extraneous variables? Controlling means that remember in experimental research, you have what is called an experimental group and a control group. It really means that when you assigned people or participants to both groups, you want them to be similar. So let's use my example before about a classroom. You want people in the experimental group to have equal background and equal aptitude. Because if one group have people who are more knowledgeable than others, then you don't have a experimental group and a control group that are similar. So whatever other variables that may impact, you want to what's called control for them. Or factor them out. Let's not worry about that right now. So what is an experimental group? It's where you manipulate at least one variable. In the study itself, you figure out how that variable affects another variable. You use 2 or more groups that are supposed to be as equivalent as is possible. You assign the participants to each group randomly. Remember, random means that you actually literally, anybody has an equal chance of being in each group. And then you compare the 2 groups. So you're going to have an experimental, some measurement before and after. And then you use inferential statistics to figure out if the hypothesis is true or not. And then you, if possible, control for as many important extraneous variables as is possible. So then there's this whole problem of, at the end of it, you get results. You want to know if the results are correct. And so you have these 2 important terms, validity and reliability. Validity basically means that the results are correct. And then there are 2 types, internal and external. So internal validity is that the experiment is within that actual experiment, there's actually a relationship between the dependent and independent variable. External validity means that anybody can generalize from that result to the rest of the population. So like I was just saying earlier that you wanted to look at if some animation tool worked to helping people learn something better, like teaching science to elementary students. I think that was actually one of my projects in one of my classes. So the internal validity is the relationship in the particular study. External validity means, but it would also be the case if it was for other students. So let's say the study was done with 50 students or 100 students. External validity means that if there was a relationship in the study itself, there's also a relationship among the people who weren't in the study. And the problem is, don't worry why, is that the more there's more internal validity, less likely there's to be external validity and vice versa. So it's a challenge to maximize both of them. Anyway, there are different kinds of experimental design: pre-experiment, true experiment, quasi-experiment. At the end of it, what you really want, if possible, is to have a true experiment. In a pre-experiment, you have no control group, just an experimental group, but then you cannot come up with some declaration of causation. In many settings, you can only do what is called a quasi-experiment. A quasi-experiment is that you're not able to randomly assign. So the best example I can think of for this is like a classroom or some other situation where there's already existing group and you cannot do the project without using those existing groups for practicality. So then you don't have actual control, and so you're going to have some issues with, are you actually able to say that the project is, you can come up with causation, but that might be the best you can do. So there are other types of studies. Correlation is, as you would expect, how we spend some time on correlation. A research study where you just look at the relationship between 2 or more variables. Now, why in the world is this different than the experimental group that we just talked about? Remember, I just said that experiments are the only projects that can definitely show causation. Why won't you be able to come up with causation from a correlational study? I actually talked about this about 2 or 3 weeks ago in class. Anybody? Nobody? Well, because in a correlational studies are cross-sectional studies where there's no manipulation of the data. Just because you see an association between one variable and the other, you have no idea either the direction, you don't know if one impacts the other, and you don't know if it's causal. It could be by chance. You really have no idea why there is a relationship. So correlation just tells you at a particular point in time, there is a relationship, but we don't know if that relationship is causal. Remember, if 2 things relate, it could be that a third thing is the cause of those 2 things relating. Or it could be what is called a spurious correlation, that the whole thing is completely by chance. I gave some examples in the past. We're not going to worry about any of this right now. So I'm going to stop. Oh, I shouldn't have stopped sharing. It's okay. I'm going to go to the next slide, because we're going to have limited time to go through things. All right. Go back to this share screen. You can see my screen?
Yes, stage.
Yeah, okay. Right, so you remember that I was saying earlier that you need to understand research design. So like just now we were talking about research design. So there are many types of research design, but you should have an idea about survey, experimental, and correlation, because we spent quite a bit of time in different ways talking about those three research designs, and they all have value in their own way. So, and we talked about different kinds of survey. So at the end of it, any study, unless it's a census, is going to have a subset being looked at. The population in research studies doesn't mean for the whole country. It means the group of interest to the researcher, whatever that group is, right? So it doesn't matter. It could be programmers at an institution, could be managers at an institution, whatever it is. And some research studies have more than one population, but there's a subset that is actually accessible. And the idea is that usually you just take a sample. And the process of selecting that sample is called sampling. And we know there are two types, probability and non-probability. Generally speaking, if we're talking about quantitative research, probability sampling is better than non-probability. Actually, in qualitative research, we basically use non-probability sampling. It's different. So in quantitative studies, probability sampling is really expected, because if the whole of statistical theory is based on probability sampling. So when you use statistics and use a non-probability sampling, you must write in your methodological limitations that there are some problems with your inferences because you did not use non-probability, because you did not use probability sampling. Everybody follow me? Just by definition. Once you use a convenience sampling or proportion sampling, or even what is called quota sampling. So in my mind, quota sampling might be the best non-probability sampling. It's still not probability sampling. So if you use quota sampling and you end up doing, some fancy multiple regression, you're still going to need to write up at the end of your project that there are some methodological limitations because you did not use probability sampling and use inferential statistics. But by the way, every single project in the world has some kind of methodological limitation, which you need to write about, and that is a key part of the end of your research study. So we need to know about the types of probability sampling. Remember, probability sampling is better than non-probability. Everybody understands why probability is better? It basically is better because the idea is if you use probability sampling, it is much more like, by definition, it is each of the ways of probability sampling is such that you're trying to get that every member of the population has an equal chance of being selected, whichever the method you choose. In non-probability sampling, no matter what are those methods, it's not known if the member of the population is equally likely to be selected. And therefore, all statistical inferences are going to be problematic. So it cannot be made. When I go that far, it should not be made, or you're going to be made with caveats. So the types of probability sampling techniques include simple random sampling, systematic sampling, stratified sampling, and cluster sampling. Simple and systematic are almost the same in my mind. Simple random sampling, either use a computer or some manual method, where essentially you have to have a list. For each of these, all of them, you need to have a list of the entire population. Once you don't have a list of the population, first you need to start about getting the list. So whatever the project is, if you're going to do probability sampling, you either need to identify the list of the population or start getting the comprehensive list. So once you have that comprehensive database of everybody in the population, simple random sampling is either using a computer random generator or literally getting a printout and selecting the sample using some kind of, like you could go to a hat and you select each of them randomly. You wanted 20,000 people out of 10,000, and obviously you're not going to use a manual process for that. Typically, simple random sampling uses a computer. Systematic random sampling tends to be where people have a list and you're doing it manually. So it's same. You have a population, you want to have a sample size. You have maybe you have 100 people, students in this class. No, there is 120 right now. I don't know. It's a lot of people. So maybe 150 of you in the class right now, and I wanted 20 of you to be in the thing. I decided that I'm going to start from number 6. And since I wanted about 20 out of the 120, maybe out of every 6 persons. So I start at number 6, and then I add 6 all the way down until I get the 20 persons from the list. And I got and that gives me 20 persons out of the 120 persons in the class. That's systematic sampling. Stratified sampling is where you have these subgroups, and you also know about the size of the subgroups. So you need to know how big each of those subgroups are, right? So if you are looking at the number of persons in the population, we have equal numbers of males and females. So that might be, so you just would have, 50-50 as a stratified sampling. But if you're looking at something else, whereas like people in university, I think there are much more women than men in university in Jamaica. So maybe overall university in Jamaica, it might be, I hear something like 7-3 overall. That sounds really crazy to me. I know it's that much at UA, maybe 6-4 overall for all of Jamaica. So if you were doing a study for university students in Jamaica at all universities, and it's really 6-4, then you would need to have, no matter what your population size, let's say your population was 200, it would mean that 60% of the 200 needed to be females and 40% of the 200 needed to be males. That's just stratified sampling. Right. It's just a fraction according to the proportion of your subgroups. Cluster sampling is where you have groups. So typical clusters is either like departments or regions in a country, and you select some amount of clusters, and then of those clusters, then you decide how you want to sample in those clusters. So like, for example, we could do a study in Jamaica and we want to know about both urban and regional areas. So we could decide that, I don't know, it seems to me there are only 2 parishes that are really urban, which is Kingston and Montego Bay, So we could decide that we wanted 4 parishes. So we go with Kingston and St. Andrew, and then we just choose 2 other rural parishes. I don't know which 2. And so that's what we do. So we go with urban and rural, and then we want 4 parishes, and then from that, now we might also then decide that we want random sampling. I'm going to do random sampling of that now because we have the voters list. So it's adults. So we want urban and rural adults, and we use cluster sampling and then random sampling within the cluster. You could do it differently. You could do clusters and then do some other sampling technique that is not random sampling. Anyway, so for non-probability sampling techniques, we have purposive, convenience, snowball sampling, and quota sampling. And do I need to go through each of them, guys? No. Purposive sampling is where essentially you select the people for the sample based on what is likely, the people who are likely to have a lot of information. So yeah, the convenience sampling is the most common type of non-probability sampling. First come, first serve. Snowball sampling is typically it's going to be difficult to find the people who are willing to be in the study. So you find at least one person, you ask them, do they know anybody else? Or if not even that, you could just even ask anybody you know, do they know, anybody who fits this description. But basically it is one where you're basically trying to find anybody who knows people who fit the criteria. Quota sampling, I would say, is the most sophisticated type of non-probability sampling. In order to do this, you still need to know the ratio of some subgroups. So for example, we know that in Jamaica, males and females are equal. So if we wanted to do we wanted to find out, what do we want to find out right now? Don't know. What do you guys want? Let's say we wanted to find out people's view about reopening of schools. In fact, let's go to something I'm interested in. Want to know if university students want to go back. Let's go to 3 choices. Want to go back face to face, or they're expecting face to face plus like online or only online for I think it was let's go with September. Everybody should be back in September and still graduating. Yeah, that could be interesting. So what we could do is we could do quota sampling different ways. We could decide that we want to do it for each year group. I think it might be different for year 1, 2, 3, 4. So if you're doing this at UTech, we can obviously UTech has a data as to how much people are in each group, and then we can send on the WhatsApp pages and Instagram pages for the union, and hopefully we get enough students that represent. So that, let's say we wanted I don't know, proportional amounts from, let's say, I don't know what the numbers are. So if it was that they were equal amounts for each year group, we would just want the exact amount of numbers for each year group. But I've heard that less people are coming in because of money problems. I'm not even sure. So if that's the case, it could be that year 2, 3, and 4 are actually bigger than year 1. And if the case, quota sampling would be less for year 1, proportional to the other 3 years. Right. So the only way we can do quota sampling is we actually know the proportion of the and by the way, we could, the example I just gave, we could actually do that study using Strata, because we actually have a finite list of the number of UTech students. But that would mean that we would need to use their email address or SMS to invite them to the study, which actually is possible because UTech has all that data. But if students were doing that study, like the students in the, let's say the student union is doing it, they may not want to spend the time and energy to go through a formal ethics application. They might just do a study and say, oh, we was concerned on another thing, and use quota sampling, which at least will give you some real data, but you would not have as much confidence as if you did strata sampling. So in general, you want to think about sample sizes. For quantitative studies, you always want lots more data than qualitative studies. One problem with qualitative studies, it takes much longer to do and takes much longer to generally to analyze. Because if you know how to do quantitative studies right, that if it's a big if, then it's just a matter of just doing them and interpreting them. Qualitative studies is actually not a simple thing to do, but we have some general guidelines. For a survey, usually you want a minimum of 100. For experiments, you want 15 per group, which basically means a minimum of 30. Because in a proper experiment, you have at least one control group, which is 15, and one experimental group, which is 15, and 15 is 30. But it could be an experiment has 2 control groups and 1 experimental group, or 2 experimental groups. So depending on how many groups, it would be 15 times that number. For correlation and causal comparatives, the minimum number is 30. And then we need to know that because there's a possibility that a study may have errors, you want to think about the 2 types: non-random sampling error and random sampling error. So non-random sampling errors is when you have a problem in how you design your research. So for example, if you wanted to find out, like, if there is a causal relationship between, you know, X and Y. I don't know what it is. I don't even know what X and Y is right now. But you use convenient sampling. Convenient sampling is a problematic approach to figuring out whether there's an experiment. So that is just problematic completely. So that's going to lead to errors in your results. Random sampling error is not a mistake of design. It is because the nature of sampling is that every time you sample, even if you do it as is expected, there is some possibility that the sample does not perfectly represent the population. So generally speaking, this should be fairly obvious. What is the way to reduce random sampling error? This is actually common sense. Would you make this sample larger or smaller to reduce random sampling error?
Larger.
Larger, because we all know that the larger the sample, it's more likely to represent the population. So what this also says that there's a study that shows that generally speaking, having the sample size beyond 400 won't have you're not going to get rid of the sampling error anymore. So remember we said earlier that no study can give you a proof. So at the end of it, you still would need to, this is having a study with a size that is as large as 400 is great, but it's still not going to lead to proof. It's still going to need to do it more than one time to get the proofs. But one study can be very useful, but you're not going to, what you can say at the end of a study is that a study strongly suggests or indicates. So you basically want to figure out how to reduce or eliminate your non-random sampling error. You want to think about how to reduce your sampling bias, and that's complicated. So we know that studies are quantitative, qualitative, or mixed methods. There are different types of studies, and qualitative research includes content analysis, historical, ethnographic, and action research. And we talked about some of these earlier. I don't know if you need to go through any of this. You should know this, actually, even for the test. So we're going to actually some basic statistical stuff. So I hope you all know that there is a difference between nominal, ordinal, interval, and ratio. So nominal is a type of data that is, the order doesn't matter, like males and females or departments. Ordinal, as in you can use numbers to represent things, but the order doesn't matter. Ordinal means that the order matters. So like age group, so 0 to 10, 0 to 9, 10 to 19, blah, 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 the order does matter. So like this, working class, middle class, upper class, the order does matter. Interval is that you have, I think interval is the example I gave for the interval is where you have real numbers, but those numbers are not divided by 0. So I just gave the example was actually an interval. So the age group areas, those are interval. And then ratio is a number that there is an absolute 0. So things like actual age, time spent reading, etc. Let's not go through this. You can read through this yourself. And I hope you all know that basically most data actually follows this bell curve, by the way. Sometimes it's positive skew and sometimes negative skew. What's actually amazing in real life, a lot of data follows this bell curve. What else here should I talk about right now? You know that there's statistical software to do all of those statistics on the screen. And the truth is, when you have the bell curve, you have most of the data that follows a bell curve fits within 3 standard deviations from the average or the mean. And these, let's leave that alone for right now. Stop share. Let's see what time it is. Okay. Oh, it didn't work. Okay. Why is this telling me that I'm logged in? Ah, it's annoying. All right, I'm logged in somewhere else. Oh, here we go. Sorry about that. Trying to open up these slideshows. Okay. Okay. So, oh, why is this not doing this? Skip. Okay, but let's just go back to the screen. Share screen. Let's go to that. So, nib editing. Right. All right. So, the thing is, we give some examples of ethics breaches, 3 examples in the lecture, and you should know about 3 basic ethical principles: respect for persons, beneficence, and justice. So respect for persons is the idea that any research you do should think about both for the participants and the research team, that there's nothing done that doesn't breach the rights of persons and respect. Beneficence means that any project should potentially have benefit to society. It's actually possible that the research may not have benefit, but that people see that it could have benefit, right? And that any project is set out so that when things go wrong, there's justice, and when things go right, there's justice. So when things go right, it would mean that there is some plan that the people who are involved and the neighborhood nearby or the country would benefit from the project, not just the people who funded the project. Justice, when things go wrong, is that if people are harmed as part of a project, that the people who are harmed get appropriate treatment or recourse. So whether it's money or medical treatment or whatever, there is some recourse because things go wrong. So there's a lot you could say about research ethics, and there are many different codes. So not only the Declaration of Helsinki, I like this particular one, the CMOS code, which gives you a lot of subsets. And we talked about many different areas of research ethics. The ones that tend to be most important in computing is privacy and confidentiality, because even not in research only, but there is so much information that is available to people in working life as well as research, that this tends to be a really important consideration. So how you protect data and how you painstakingly figure out how not to give that data to other people is very important. This is probably the area of research ethics that is the most controversial, research design. So there's often debate on this topic. The idea is that if your research is, if the research study design is inherently problematic, you shouldn't waste people's time and energy and money doing the research. So if you got funds to do research, or if you take up people's time and say, oh, would you mind doing part of the study? At the end of it, because you designed it poorly, it won't advance knowledge inherently. How can that be good for the world? The idea here is that if it's badly designed research, we should not do the project. Some people say, no, but the students are learning. But how can you be learning if you design bad research? That is why at the end of it, you do research, try to find a good supervisor or other people who can tell you your research is not well designed, so you don't waste your time before you start, for obvious reasons. Generally speaking, we should not deceive people in research. There's exceptions, but anytime this is an intention, it must go to a research ethics committee. With children, you must ask for assent of the children and permission of the parents and guardians. But obviously, children are too young to give assent, like when they're under like 6, it would only be permission of the parents and guardians. If there's a situation where it's in a particular location, like in a school, you'd ask the principal, or some other setting where there's an authority, they would also be asked. In fact, in general, in a study, it's not as children. In a study where there is an authority, if it's just adults, you normally need to also ask permission of authorities, not just research with children. Obviously, when you do studies, you need to not falsify data, and even how you present the data when you write it up needs to not mislead people. Like one common way to mislead people is to, when you have small numbers, use percentages or fractions, not indicating how small the numbers are. So there's a lot of, so not lying in research or not deceiving people is more than not presenting data wrong. In fact, on another note, what's important here too is to present the data. I've actually supervised more than one major project group where they get results and they don't want to present the data because it wasn't what they expected. You cannot fail major project or any research, well, I don't know within others, but in computing, you can never fail because you present data you collect. So at the end of it, you present your data and you analyze it. And even if you get even if your hypothesis is not, the results is not what you expect, you just present what you expect and then discuss that. Obviously, it's wrong to plagiarize. And is there anything else here I want to talk about? No, that's enough of that. Go to one more thing, and then I'm going to ask if anybody has any questions. Because we really don't have time to like literally do everything in this 1 hour. I'm just going through everything really quickly. So, I wonder if I should go through. Maybe I should do this too. I was going to do. Let's do this. Right. I need to share screen. That makes sense. So I'm going to forget I wasn't sharing screen. Right. So remember that we said that qualitative research is also important. So a lot of people in computing tend to prefer quantitative research, but at the end of it, exploratory research or research where you want to like get what is called rich data, you're not going to get it unless you actually literally do qualitative research. So you can get useful information that is detailed and learn about a phenomenon in great detail from qualitative research. You can also give voice to silence people. That doesn't tend to be what we do in computing research, typically. And there are many ways to approach sampling in qualitative research. It really depends on what's the goal, and you can read through this. It really depends on the goal in the project. So we already said from earlier that the sample sizes tend to be small, and you go on to what is called saturation, meaning that you tend to aim for 30, but if it is that all the answers are dissimilar way before you get to 30, you can actually stop the data collection because you actually have seen that there's a pattern. As with everything else, you need the permission from the Research Ethics Board. There are some differences in how you get those permissions. Because you're going through in-depth interviewing and observation, qualitative studies are going to have usually cameras or audio recorders, and so the permissions need to be very clear in advance. You need to have given to a gatekeeper, and the gatekeeper is the authority, like I was saying earlier. So you need to have the authority agree to the study, and you explain why you're there. Usually this is with a letter, and sometimes that letter is preceded by an oral conversation. And these are the types of data you collect from a qualitative study: observations, interviews, documents, and audiovisual materials. And then it depends on which type of study you're doing. Is it going to be a participant or a non-participant observation? Makes a difference as to, and what you do, it depends on the type of study as to which is appropriate. Usually with these things, you need to read what other studies have done, figure out what makes the most sense. Remember now, with all research, you're building on the shoulder of giants. So you look at what has other research done before, and unless you have a good reason, you follow what previous people have done, even though it's a different setting. So in observing, you're going to be like, after getting the permission, you are trying to like not barge into the place, you're making observations. So even if you are a participant observer, you wait for a while before you start to participate. In a non-participant observer, you're also not going to observe. Usually like that's either in a lab where you can have a window so you can look in without anybody observing, or if it's in another setting, it has to be that you stay around long enough that people like don't even notice that you're there anymore. So interviews, there are many types, and it can be face-to-face or virtually. Clearly, since COVID, we've been doing lots of virtual interviews, and usually they're transcribed and recorded and then transcribed. They can be either focus group, which is a group of people, or one-on-one. And in an interview, you're going to think about probes and what's the other thing called again? I don't remember the name. So you can do structured, semi-structured, and unstructured interviews. And any kind of interview, you're going to set up the questions in advance so you can actually figure out answers to your research questions. By the way, both for qualitative and quantitative research, there should be a really good match between your research questions and the data that you're collecting. I don't understand why, but a lot of people who do research actually realize that when they finish the study, many new researchers, that they haven't collected some data that's really vital. So you have to figure out what are the variables that are important in your study and make sure you ask those questions for obvious reasons. Documents can be useful for projects. There's a difference between a literature review and documents that are like in organizations that could provide data that helps answer your research questions. So it could be public and private records. It could be text data that's available somewhere related to your research question. Obviously, you need to get permissions, and if you get the permissions, you will scan the documents so you could like keep them during the time of the review. Depending on the project, you might need to destroy the records afterwards or return them to the source. Audiovisual materials are also useful, obviously, to get permission and check that it is accurate. Right. So for any qualitative project, you want to use protocols. Those protocols is basically the set of rules that you're following. And give some examples here. It's not even a thing. So like in general, for interview, you have like a header, you come up with the icebreaker you're going to use, the research questions and the probes. And with observations, you also have like a heading, and then you have two columns, a left column, which you have the descriptive notes, and the right column where you have the reflective notes. And you also sketch the site. And the thing is, many data collection for qualitative can be challenging, having sufficient time, because sometimes they allow you to do it and then they want to say, okay, but you need to leave now. There are some challenges with being an observer and not having an impact on how people act if you're observing. People sometimes change their action because you're observing. In an interview or a focus group, it goes better if you build good rapport with the participants. And clearly there's always needs for permissions, and that can be tricky depending on the nature of the research study. Let's see what time it is. 6:06. Out of time. So I guess the only other thing I would actually spend time on, although we're out of time, is looking at literature review. But I think we spent so much time on literature review in terms of, at least for my tutorials, in terms of my class, it's only a matter if you were to look at that. So anybody has questions or concerns? So the test is April 25th at 5 p.m. Expecting you to come on with to log on to Zoom call, as well as to do the Zoom link, as well as to do the test using the link which will be provided on the Moodle platform. So we're to put the link on the Moodle platform, but expect everybody to log on to the same Zoom meeting that we're using right now, and I'm going to provide instructions. And please, just for those who want to, please, you should not be sending other people, because I've done this in the past. People are sending people information and then afterwards complaining that they didn't get all the instructions. Yeah, is everybody hearing? You need to come to the test on the Zoom and not complain afterwards that you didn't hear all the instructions. That's foolishness. This is an online test where the requirement is you need to come to the Zoom platform where you get the instructions. Everybody is following?